Well, good morning, everybody. It's 10 o'clock on March the 11th, and this is number 48 in the weekly coffee hour series sponsored by Lancaster Area Woodturners. I'm John Kelsey, and I'll be your host this morning, as every Thursday morning, or mostly, ably assisted by Doug Resor, who is your best resource if you want to share pictures. Send them to Doug. He'll show them from his place, and all you have to do is talk. You don't have to figure out how to share your screen. If you do want to try sharing your screen anyway, we'll stay with you for a little while you fiddle around with it. The other way, of course, that you can show work is to hold it up beside your face or in front of your face. Let's see. I have a list left over from last week of people who asked to show and discuss stuff, and I'm going to go through it. And I think most of you know who you are, but if there's somebody who's got a burning desire that I don't already know about, raise your hand, please, so I can. Let me see. Okay, my list includes. I'm going to start with Kai, and then I'm going to ask Bruce Lamb to introduce himself and show some pictures. Bill Davis wanted to show some stuff. Ron has a short video that I'm looking forward to seeing. Charlie Nelson, Ted Luttrell, and if Ernie Conover clicks on, he's got a book review. So that's going to be a full hour already, and I haven't even shown you any of what I'm working on. So there you go. Let's see. There's Ernie. Good morning, Ernie.
Well, John, I could.
Sorry, I found my computer was dead and I had to go find it.
I was going to say.
For it.
Charlie, you're trying to talk.
I was going to say I could take, if there's not enough time, I could take pictures. It might be better to send them to Doug and do mine next week.
That works pretty good.
You know, if there's not enough time, it's up to you.
Okay, well, I prefer you do that just because of the screen crumble thing. And plus, you'll be glad you have some pictures that are good enough to share. We share finished work here. We also
That'd be the way to go.
We share finished work, we share work in progress, we share jigs and fixtures, we share tools, we share techniques. This isn't just show and tell for finished work. We can also share problems. We've had quite a few interesting problems. One of the problems I've been having lately is steady rests for long spindles, and I'm interested in designs for that. So if anybody's got a good spindle to steady design, I wouldn't mind seeing it. You can let me know about it, and if you got a good one, bring it next week. Also small tools. Some of us have been making spheres and other small things that require little tools. And Kai has a slideshow showing about making small tools. Am I right, Kai?
Yes, I have.
You got the floor.
Okay. I'll share it. Okay, you should be able to see the PowerPoint now. Is that working?
Yep.
Yes.
Yeah. Great. So if you have questions, please ask them. Otherwise, I just go on talking and talking. So if there's a question, please tell me.
And I can see, before you go on, I'm just telling you, I have a big screen and I can see all of you in a thumbnail view. So if you're waving your hand, I'll spot you.
Ah, great. So you can tell me then. Yeah. Okay. Some time ago, during a morning coffee hour, someone showed a homemade tool. And there was a request for more homemade tools. So I thought of showing you my homemade tools for small turnings. Okay, just to give you an example, what I use them for, this is a spinning top, and it's designed as a box. So you can unscrew the lid, and it will work as a spinning top as well, because you can put your string through here and then a holder, wind up the string and then draw the string and it will start spinning. So that is not very small. It's about a bit more than 3 inches tall. But if you open it inside, there are smaller spinning tops, and these are about 1 inch. So, and this one, for example, has got a captured ring as well, which you can see here. And I made some tools for small turning and also for making this small captured ring.
I'm blown away already, Kai. That's fabulous.
It is. Wow.
Thanks. Okay. Another thing I make is jewelry. And these are little glass bottles. The opening here at the lower part of the cork is 1/4 of an inch. So the spinning top design has to be adjusted so that it fits through there. And they have got captured rings as well. And they do really spin, but only for a short time because the mass is really low. And so if you start them, they will spin fast, but only for a short time. Okay, so that's what I need the tools for. And now how they are made. I use mostly round high-speed steel bars, which you can buy on eBay, for example. Those that I use mostly come from China, and they are not really expensive, maybe about $1 or $2 a piece, depending on the length and the diameter. You get more expensive ones as well. And they also come as square or flat bars, so you can use them to make other tools as well that are not round.
Is there any particular grade of high-speed steel, or if it's marked high-speed HSS, it's good enough?
It's good enough for wood turning, as metal is harder than wood anyway, and I have the experience that the material you get from China holds the edge quite well. So of course there are better qualities, but they are more interesting for metal turning maybe than for woodwork. So the cheap stuff from China is okay for my purposes. Okay, so that's what you can use them for. For example, this is a little parting tool that I ground from square stock. A little skew chisel that I ground from round stock. And this is a scraper. So I ground a scraper profile at both ends of this HHS bit. Okay. That's what you have to watch out for when you grind them. Is there a question?
Yes. Do you hold them with your hand, or you slip them into a tool handle?
I made special kind of handles for them for grinding them, which I will show later on. Yeah. Okay, the good question. Because in the beginning, I actually tried to hold them by hand, but it's sometimes it's a bit tricky to get it right, and sometimes it's a bit dangerous if they are really short and you hold them by hand. So it's better to put them into something to hold them. Yeah. Okay, so the grinding. As all scrapers, they need to have some kind of angle at the front, for example. So that might be 10 degrees or something like this, so that you have 80 degrees here and 10 degrees here at the cutting angle. And then I grind the sides a little bit back to get some relief on the sides. If you imagine your tool in a gap that you put a parting tool into, then you don't want the sides of the tool to touch your groove that you are making. So that's why they are ground back a little bit on the sides.
Why a little bit? Do you mean 5 degrees, 10 degrees?
Yeah, I think 5 degrees will do. 10 degrees is okay as well. Because you don't use the sides for cutting, it doesn't matter that much.
And the front angle, what angle are you using there?
About 80 degrees, maybe. You could do 85 or 75. It will still work, I guess. Yeah, it depends a bit on the hardness of the wood that you use the tool for. The harder the wood, the steeper the angle that you want, so that it lasts for a while. Okay, an example is this recess tool. Here you can see the profile that I have just shown. If you look from the front, so the sides are relieved. That's the top view, and here you can see the side view. So that's the cutting angle. Yeah, it's a bit out of focus, this photo on the right hand side, but I think you know what I mean. Right, and that's the use of the recess tool. If you do hand thread chasing, you need a recess here so that your chaser doesn't hit the lid of your bowl and rips off the threads.
How thick is that piece of metal?
This year, how thick it is?
The overall piece of metal, how thick is it?
Ah, okay. Let me see. It's maybe an inch wide and 4 millimeters.
Fat eighth.
An eighth of an inch, a little bit more than an eighth of an inch thick.
Okay.
Okay, and that's for shaping and sharpening the tool tips. I put an extra wide or large rest onto my old grinder, so that I can also use the sides for grinding, which you actually shouldn't do. People always tell you, but if you have these very small tools and you touch it just lightly, it's okay for me. And also, of course, the front, and I can, if you grind a round profile onto scrapers, you can just start at one side of the scraper and then move it in an arc all around here so that you get a nice round tip. Another thing you can do is put the HHS or the high-speed bar into a vise and then use some kind of Dremel tool or Proxen tool to shape it. And Jim asked earlier on, these are holders for these HHS bars, for the round ones, so that it's easier to put them onto this flat surface of the grinder and keep one angle, and it doesn't kind of roll over like the round one would do, or the round bar would do. So that makes it much easier.
Make those, or are those purchased?
No, I made those on my lathe. So I just let the lathe run at a low speed, and then I drilled these holes and then tapped some holes for these grub screws to hold the bars. I also made some jigs for my Tormek, but the Tormek isn't that good for shaping the tips, except you have very small tools. So that's more for sharpening. And I made them for at different angles for skew chisels, little skew chisels, and also with a straight edge. And that's how I use them. I put them onto the grinding rest, I think you call it, of the Tormek. And there is one piece of wood down here, then another block glued to it that has the same thickness as the tool rest, and then this piece on top. So that's the bottom piece. That's kind of the spacer, and that's the top piece. And, oh, wrong direction, sorry. And also I use a clamp to hold it in position so that it doesn't move forwards and backwards. And that's my holder that I showed earlier on, or one of them. And then I put the bar into it so I can sharpen it. This one hasn't got a cutting edge. I just put it for photo purposes in there so that you get the idea. And then I just have to push this jig against the this little platform here, and then move it from left to right, and it keeps the angle, and it works really nice. This is a Pointy tool. Some people call it a 3-corner tool. I don't know why, where the 3 corners are, but and that's also homemade. The ferrule is homemade from brass, and that's another bit of high-speed steel bar. And in engineering, first I tried to grind these tools freehand, but for me it was quite difficult to get 3 flat sides onto the tool and have a nice point. So an engineering friend came up with the idea to use this hex bar here, and he drilled a hole into it for me. And if I start in this position, then leave out one flat and put it on this position, or that goes on the table then, for grinding the second flat, and then leave out this one and put this flat onto the tool rest for grinding the third flat, I get a really nice point, and that works really nicely.
That's a very clever little, that's a very good idea. And you could make that out of wood too.
Yeah. You just have to think of a way to put in the screws that hold the bar into position. Yeah, but there should be some way to do that.
Barry
Maybe
Price,
some
I
little
see.
inserts or something like that. Sorry?
Barry, you asking a question?
Barry?
I didn't
Price?
ask a question.
No,
I didn't-
Okay.
We thought you were waving around.
Oh,
So
no, I just had my hand.
I'm saying Barry,
Back to Kai.
Okay.
Barry can make something like that.
Oh, Barry can make something like that. Yes, for sure.
Oh, it's always good to have metal workers in your club who can help you.
Barry has a very nice metalworking club.
Good. So, and then once you've ground them to shape, you can use diamond hones to resharpen them, so you don't have to grind them all the time. That is much quicker and takes only away a little bit of metal, and you can still maintain the point of the tool.
Kai, have you ever considered a means of making a beading tool? I've been trying to do that, and it requires, I guess, like a radius edged grinding disc, like say a 1/4-inch thick grinding disc, to grind the half round, to grind the flute out of rectangular bar to make a beading tool.
Barry, I did that with some diamond tools that you can get for your Dremel.
What you mean? You use the diamond tool to grind the trough?
Yeah, they fit in a Dremel and they're about 1.5 inches long. Get a whole set of them. They're pretty inexpensive too, but it works well once you have it. I took a triangular file and started it, and then just used the Dremel tool with that.
Yeah.
Kai's coming
Actually,
up with something like that too.
Yeah, I actually ground a hook tool for turning out of this high-speed steel bar, and used the Dremel tool and also these little diamond tools. I got inexpensive ones from China. They don't last that long, but then once one is blunt, you take the next one. They are very low cost. So, and it took me about 3 hours to grind this this hook tool. I can show it sometime, but I don't know whether it's worth it. But I just wanted to try whether it's possible. Okay, just let me go on with the small tools then. This is a ring tool, and here I use the disc in the Dremel tool to grind this little round bit here.
That's pretty close to what you're asking about, Barry.
Yeah.
Yeah. I was looking more at like at a longitudinal flute down like say 1 inch of the back that you would put face down to make a beading tool. I'm thinking of a beading tool that was demonstrated a few weeks ago on that professional demonstration where the gentleman made Southwest baskets. Harvey Meyer, I think.
Yeah.
Okay. This is a gouge I turned or made a ferrule and a handle for this gouge because it was far too long. It came in a set of miniature turning tools, but it was far too long and there was a lot of vibration in there. So I made that ferrule here and took the gouge out of the original wooden handle and put it in here. So now I can push it in as far as possible and hold it with these screws. And the overhang is smaller here and it doesn't vibrate that easily. So that's another modification. Maybe it's not a homemade tool.
Another good idea.
So these are the tool handles. They've got this brass ferrule here. I took a photo of a metal ferrule that a metal engineering friend made for me for a bigger tool, just to give you an idea. But brass is quite soft, and you can scrape brass with high-speed steel tools on the lathe if you're patient. So I made something that looked similar in like this one or to this one. It also has got the step here, so I can put it into the wooden handle, and this bit goes into the hole here that I drilled, and this bit also gets 2 holes for crab screws so that I can hold the tool, and I drilled the handle so that I can push the metal bar a little bit into it, so that I can control the overhang and just pull it out as much as I need or as necessary.
Do you find that an insert like that really changes the balance of the handle with a pretty heavy piece there?
Yeah, it makes it heavier, but that's not a disadvantage. I think sometimes it even takes a bit of vibration out of it, I think. So it's for me, it's all right.
I know even with small spindle gouges, I kind of like the aluminum inserts because the steel ones just tend to make the tool too heavy. But
okay, aluminum would be another possibility, and I think that should be possible to work on a wood turning lathe as well if you're patient. It's soft enough, or should be soft enough. Okay, and these are tiny ring tools that are ground out of nails. These were for these jewelry things that are put into the little glass bottles, the spinning tops. And here I wanted to ask you whether you have got something similar in the States. The tool consists of 4 parts. One is a file handle. Of course, you could turn a handle yourself as well. Then this kind of screw, which I found is called a stair bolt. Is that right? Is that a stair bolt?
Yeah.
So I screw that into the handle. Then I have this threaded sleeve, which is used in installation in Germany. So I put that on there. And then we have these special nails. They are a bit old-fashioned, but they are still produced. They have got a thread here that fits into the threaded sleeve. And then I can grind the tip to the desired shape. And once it breaks or it gets too short, I just unscrew it and put another nail in there, and then I can grind a new tip to it. And these nails in Germany are called oboe dübel. I guess that's a plug in English. So oboe plugs. And they were originally used in electrical installation. These nails were either hammered or shot into the wall, and then the cable clip was screwed onto. Here you can see how they do it. Yeah, they screw it onto the thread that sticks out of the wall, and then they put their cable under the clip. Do you have something like that in the States, or is that uncommon?
I think there's quite a bit of hardware like that if you look around, yeah.
Yes, it's technically called a Nelson stud, and they can be shot into concrete as well with a ram set, which uses a 22 cartridge to fire it into the concrete.
So it's called a Nelson stud. S-T-U-D, is that right?
Yeah.
Yeah. Okay. Yeah. I'm asking because I thought of writing a little tip maybe for the American wood turner or wood turning fundamentals or something like this. And then it only makes sense if the hardware is available in the States as well.
Kai, that one bolt you showed there with the wood screw and the machine threads on the other end, that's called a hanger bolt. Typically, and I've seen it called a hanger bolt.
A hanger bolt.
Put that in the wood, then you got the machine screw thread on the end.
Okay.
I saw that nail with the thread on it.
Ah, thanks a lot. Because when I looked it up in the dictionary, it said stair bolt or hanger bolt, and I didn't know which one is the right one, but a hanger bolt is better than. Okay,
Yeah, that's familiar around here.
so a hanger bolt and a Nelson stud.
And the thing in the middle, depending on your thread, could be off of a, I don't know what you call it, but it's you get them at the hardware for adjusting screen doors so you don't sag. They have a reversing threads on either end.
That's a turnbuckle.
Thank you. That's right.
A
That
turn-
turnbuckle would have left and right. This piece may not have the left and right.
No, that's just one direction, and
Yeah.
they sell them in Germany, for example, for plumbing installation. When they hang pipes on ceilings, they and they need to adjust the height or maybe make it longer. They put these in between, so the stud goes into the ceiling, for example, and then they put these in between, and then a bit of threaded rod, and then they have their fixing that they put around the pipe.
That would probably be called a connector nut rather than a
Connector nut.
There'll
turnbuckle.
often be hex, or there'll be a hex section in the middle so you can put a wrench
Yeah,
on.
there are hex ones that
Yeah, we have the hex ones in Germany as well, but I like the round ones for the tool better. So I try to get round ones, but they are not as common as the hex ones. You're right. Okay, great. I think that's it.
Okay.
Yeah, thanks a lot.
Thanks, guys. Good.
Thank you.
Thank you.
Yep, thank you.
Yeah, you're welcome.
Okay, now let me see. Jim Laporte, you're waving your hand? You're muted, Jim. Yeah, you're still muted.
Sorry, I was just congratulating.
I thought you were going to ask a question or offer some more on anybody else on small tools that you want to say before we move on. It's almost half the hour.
Do you use magnifying lenses on your glasses to see that small a thing when you're turning?
Yes, I do. I have special glasses that I use instead of my normal glasses, and they have magnification of 2. So it's twice the size then.
Use surgical loops?
Yeah, something like that. It's a cheap one that I bought on the flea market, but it works pretty well. My dentist has a nice one that he uses for root work if he has to look very closely, but that's more than 1,000 euros in Germany, so that's too expensive for me. It would be nice to have one of these, but the cheap one with a magnification of 2 is all right for me. And
I have visors that go up and down that have those level of magnifications that work pretty well in that situation.
yeah. I also have a loop lamp that I can look through, but I find the glasses more flexible than the loop lamp. So, yeah.
You find yourself moving your head up and down to stay in focus, whatever you're doing.
But that's essential, yeah. At least in my age, it's getting more and more essential to use loops and special classes and stuff like that.
I'm going to move on from this now. Thank you again, Kai. That was a great little show. Bruce Lamb is with the Baltimore Club of Woodturners, and he had asked to introduce himself. So I'm going to, Bruce, are you ready to go?
Sure. I am with the Baltimore area turners. Although I can say I lived in Bucks County for 20 years, so not complete stranger to the area. And I was going to take your topic fairly literally and talk about what I'm working on, and probably pick what I think I do worst. So be interesting to get some feedback and what you guys see as different. But I want to talk about hollowing. You guys have been talking about thread chasing and such. I imagine there must be some hollowers in the group. This is the first piece I ever hollowed with a professional demonstrator standing over my back. It's a piece of Florida mahogany. And
Move it over a little bit. Move it over a little. Yeah, that's good.
That better?
Yep.
Use kind of standard tools. I said kind of Kelton hollowers is probably what I used. It's still fairly heavy, and the finish inside is nothing to write home, and it's fortunate you can't see that well in there, but it is what it is.
I'm getting my finger in there and feel it.
You want to go in there and feel it?
You make the hole small enough you can't get your finger in. That's the trick.
That's an interesting thought, to make it so small you can't get it in.
Hold on a second. Whoever's phone is ringing, please mute yourself. Thank you.
So after that approach, I went and I tried, and I've had for probably 2 years, the D-Way Tools Hollower, which is a arm brace outrigger kind of outfit. And I had some success with it, felt all right with it, but never felt comfortable with it. The type of cutter that's on the end is fairly broad, and you can make a mistake in a hurry if you're a little aggressive with it. And it's also very important how you turn that cutter within the tool. And I find that that was just more of an effort than I really wanted to make. So oddly enough, when I was in Lancaster, I caught Trent Bosch's talk and wanted to see if I could try his tools. So let's see if I struggle or can bring this up. Everybody got that?
We got it.
Yes.
So this is the Trent Bosch Hollower. I was kind of amazed at the amount of degree of freedom you have in moving it. I thought I was going to be feeling fairly rigid with it, and it was going to cause me some problems, but it really moves quite flexibly and quite easily. And this is a laser attachment on the top, which is pointing out towards the edge here. The system is really meant to work off the end of the lathe. So if you've noticed, I've slid the headstock forward on my lathe. I have controls that are movable. So my controls are up here where you're working, and it just felt really comfortable. I picked, I think, a ridiculous first try piece, which was kind of a 6-inch round piece. It was a little less than 2 inches deep to put on here, which probably wasn't the place I should have started, but it's okay. It let me use 3 tools. I used the straight tool, a slight bend, and a severe bend to get all the way in the top. And if I show you the piece off the lathe, it looks wonderful, but I'd be lying to you as to what the inside really came out. I was sure that I was chasing a ridge on the bottom, but instead I was poking right on through, and I did blow out the bottom on this piece. But having said that, the finish on the inside was reasonable. I really liked that right off the tool finish. I was able to get into the edge of it quite well, and I was able to get the lid, about a 1/4 inch thick, and I felt pretty good about that as a first failure. Not too bad.
Were you using the laser for that?
I was using the laser. The interesting thing is, in this case, the laser is really pointing off the back. If you realize that it's not on the edge, it's falling off the back towards the chuck. And I just ignored what the laser was telling me. So, I screwed up. The tool works and the laser works quite well, actually.
Yeah, that's a pretty nice surface on the inside of that. One of the things that they say when you're beginning hollower is make a couple of pieces and bandsaw them in half, and then look at your wall thickness to see how you're doing. And
I simply saved the
you
step
did it
on
here
the-
inadvertently.
I'm sorry, go ahead.
One of the biggest tricks is to trust the laser.
Yes, I think that's true. And again, I didn't feel disappointed by this. It was the first shot out of it. This is maple, and I thought the finish on it was pretty good on a dry piece. So I spent most of the weekend actually seeing what else I could do. This is more of a, let's see, this is a genuine mahogany, and I like this really deep jaw chuck. I don't know if you guys have played around with jaws. It seems now when I buy chucks, it's not really the brand as much, it's what jaws I can find and do I like them. But this one has really deep jaws. It's a record power chuck. And this piece, which was about 10 inches long, is just rock steady in that chuck, even when you're spinning without the tailstock, which I love.
That's a fairly short tenon in that chuck. You could have had a longer tenon for an even better grip, or not?
I could have had a longer grip. I think it's longer than it looks. I think that tenon was a good 3/4 of an inch, but it doesn't look it. And so I sculpted out a fairly standard shape, and then was able to hollow it quite well. This is a little LED that I have for making some of the smaller things. I was wondering if I should have just stuck the LED inside, but it seems to work pretty well at the end of the tool rest to shed some light in there. And even to seeing the bottom a little bit when I'm in between tool changes, it's pretty handy. So this piece, which is about 6.5 inches tall, I guess Kai would appreciate this. Well, no, that's in grams, but yeah, it's grams, so it's more metric. It's about 5 ounces, so it was a pretty light little piece. And I felt pretty good that I had gotten down to what I really needed. It was pretty clean down here, and I just left a little bit in the end because I was still paranoid. So by Sunday, I decided I'd get a little more adventurous and try something in more of a classic vase shape. This one is a little longer than the other piece, and this was made from a 5x5 piece of cherry, and so it was pretty hard, but it wasn't terribly hard for a hollower. But I was surprised how much wood there was to remove in the middle here by the time I started going at it. But it worked out pretty well. So this is the piece drilled out and ready for hollowing, and then the system going on in. And here the laser is going to be mostly off the side, and worked really well for me to get in there. And even the end here, obviously I did some of that with a spindle gouge, but I also opened it up a bit with the tool. And so at the end of the weekend, I wound up with 2, I thought, fairly nice hollowed out pieces. Maybe threading the ends next for me, but it was what I'm working on.
All right. Comments and questions for Bruce?
Bruce, on that one, you blew the bottom out. I'd rechuck it and turn the bottom round and put a nice foot on it. I think that'd be a great piece. Maybe walnut or something at contrast.
I thought about it, and I decided not to put more effort into a failure. I have another blank just like it, and I won't quit. In fact, I have a blank like it in walnut, another one in maple, and I will go back to that shape, yes.
It's not a failure. It's just an opportunity for more artistic expression.
And a little firewood, maybe, too.
I chalked it up to learning.
Other comments, questions?
How long have you been turning now, Bruce?
Much longer than I usually want to admit. I think I bought my first lathe in the 1980s. It's kind of funny because it was a little 12-inch Craftsman lathe, which I bought used, I believe, in 1982, and recently donated it to a senior center here. It's still running. But I think with my career taking me kind of all over the country in pieces, my amount of turning I did over the years was not that large, probably until about the last 5 or 6 years, which I've really accelerated what I've been doing.
Thank you.
Oh, do you know, Bruce, there are collectors out there collecting those Craftsman lathes now. Sometimes they go for a rather nice price on eBay.
Well, I felt nice donating it to the senior center. It gets used. It's all good.
Thank you very much, Bruce.
The range of motion on the tools that you usually like. The tool rest is just a pain in the neck getting that piece right. It doesn't go down to low speeds. So, you know, it's certainly limiting, but still makes some nice pieces.
So let me ask, how many of you guys have hollowing rigs like Bruce showed us? Or first of all, how many have them? 1, 2, 3, 4, 5, 6. Okay. How many would like to have them? 7. Okay. So it's of interest to at least half of you, the topic of deep hollowing and hollowing rigs. Am I right about that? Looks like that's right. Yeah.
Jim Bowman talked to me about it.
I'm sorry?
I said, Jim Bowman talked to Doug Reeser about it.
Yes, I did. And I
got a deal for you.
Oh, okay.
Ron, you ready to
do that?
Video?
Yeah, I think I can get this up.
Okay, give it a shot.
Oh, there we are. All right, share screen.
Yeah. And then play the video after you shared. Here we go.
All right. Bill Tchaikovsky made that bowl. I don't know if you can see my image. I have the
Yes.
twin spout bowl in front of me here. At any rate, he was talking about making all the jigs and so forth. Well, what I do, and you can see I drew the drawing on it. I'll start the video up here. I drew the image on the wood. This is a 5.5 wide, 4 inches thick, 12 inches long piece of cherry. And the video is not playing. All right, looks like it's coming up now. So I drew on there, and then you can see the spouts are drawn, and they're very faint. You can see the center lines going down at an angle. You can see my cursor?
Yeah.
Okay, and then down at the end, I drew perpendiculars to it. It's about 8 inches tall. And the width of the bottom is about 4 inches. And so anyway, what I have on the video is where I draw these lines for the angle that I'm going to drill. I set my sliding bevel, and I'll set that up to get the angle you want here, and then go around the corner and draw a perpendicular to it. And I did that on all 4 corners, and then I set a miter gauge for the bandsaw at that angle, and then I was just able to take this thing, go across the bandsaw and take the corner off, and then I've got center lines coming down the piece. I bring it down around, and I can mark centers, and then I'm holding it in a chuck over here on this side, and then the tailstock up here. Then I have a 12-inch long drill, 1/2 inch diameter, and I'll drill down through there. So
you're rigging up the workpiece on the lathe so that you can drill that hole at an angle rather than going to the drill press, for example.
Yeah, I held it right on the lathe in the chuck on this end, and this is centered up, and then just drill through with the drill chuck, drill into it, and then I turn over to the other corner and I can drill the other one. And then I can
you just put that on the drill press
on the center of the piece, and was able then to turn this part. And I kept this end on until I was all done hollowing. I hollowed the bottom, and then I ran the plug for the bottom. I plugged that, and I turned this down now to this is about 5/8 inch diameter tenon. And I can hold that in the pin jaws in my little chuck. And after I did the band sawing in here, then I was able to use I used a Fordham rotary tool in my Dremel to do the rounding. But I'm holding it in this little tenon back here, and I can bring a tailstock up for a while until I start working in here. But I can do all of this outside with the tailstock up in there. So I didn't make any special jigs or anything for it. It's just a matter of holding it on the, and that's what I wanted to try to show on the video.
Well, we'll practice. We should practice screen sharing off the coffee hour to get it right, because it's a struggle, and I appreciate you giving it a try. Yeah. And I'll give you a call later, and we'll give it a little practice. Now,
I got it, John.
Okay. Any more questions for Ron on that process? My question again for you and for Tatkowski is, how come you wouldn't just prop the piece up on wedges and drill it on the drill press?
Well, you've got to find the angle, the proper angle, and then you have a pretty small base to sit on whenever you cut that angle off.
Okay. Okay, we're going to go to Ted Luttrell now. Ted?
Hi, I'm from Vermont. It's going to be 57 here today, Yahoo. And I'm in the northern woodchucks of northern Vermont, but I've been enjoying the coffee hour here. I wanted to show this project because it's something that my daughter asked for. She asked for something to hang her long dangly earrings on. And so I came up with this. And I did this because I wanted to try, drilling the holes in a piece of wood and see how it turned out. I like the way it turned out. I had some problems in doing it. I've never done it before, And my initial problem was I used a Dremel tool and it burned. So I bought another Dremel tool that that I could slow down. You know, instead of 30,000 RPM, went down to 10. That worked much better. But I still had to pre-drill it and then use the Dremel tool to widen the hole. So yeah, there's the next one. So you get you can kind of see what's in. Obviously, the little holes on the end are for her to hang her earrings on. And anyways, I like the way the project came out. Next time I'm going to make it a little different. I do have some questions. Does anybody have any experience in drilling these kind of holes, and how do you keep them from burning? Or are you able to do it without pre-drilling, and how do you keep it from burning?
I did this once with stuff with a Dremel tool as well, and I got a milling bit, like the tiny, instead of a regular just grinding. So it actually has a side grinder on it, a side miller, and it worked really well on this type of hole. The biggest difficulty was just getting it from going too fast. But literally, they're about, it's just maybe a half-inch long milling bit for a Dremel tool. So
I'll have to try that. Is it now? I have the little metal bits, but I don't know that it's considered a milling bit.
Well, it's a bit with where the chisel is literally on the side of the tool as opposed to the end, and it's got a little spike, so it will drill through. But there's more meant for going around the sides as opposed to the ends of a drill.
Yes,
so,
yes.
So it is literally like a little milling bit.
Yeah, that's what I have, but so I had to pre-drill. They have the one I use has you can cut down with it, and then it has side milling, but you really have to slow them down. But I didn't like drilling the holes with it, so I ended up pre-drilling, which gave me a little breakout on the bottom, which I didn't show here.
Yeah, it does. It does, and you have to be careful with that.
I bought some carbide tools that are, one of them is like a spear shape at the end, and then it really, you can just push it right through this stuff, and it does a nice job.
I thought about that. I'll get some and try it.
Yeah.
Doug, that mill that you have, is that an end mill?
Yeah, I think so. I can't remember for certain, Ron. It's been a while since I did it.
Because I have a 1/4-inch end mill that using a router that does pretty good. You could probably drill down into a piece like that, but of course here you'd want something smaller. But
yeah, it was probably about a 1/16 or maybe an 1/8 of an inch diameter tops.
And that's what I think you're talking about there. There was an end mill that would go through, and then the scoops on the side would allow you to make the side of the hole a little bigger if you wanted to.
Yeah.
Well, good. Thanks, guys. I appreciate that. I'll get some more and practice with it.
I have a question.
Go ahead.
Yeah.
How did you lay out the holes? It all looks very precise, and
it's not. It's intended to be random. Although you lay out, what I did lay out was the 3 pieces cut. So the rim, and then the 3 more solid pieces going to the center. You draw that on the wood, and then I started drilling holes inside that area. I tried not to make them too uniform. And then I did it with a drill, and then I took the tool we've been talking about, and I just did I went around the sides of the hole, trying to make them more oblong, so it looked more random.
I watched several demos by Ben Foe years back, and that was his point. You made random shaped openings, and your pattern is all random shape.
Right. That's what I tried to do.
Yeah.
And when you did the holes and expanding the holes, did you start from the center of that lattice work, or did you work from one edge?
I worked the edge first, because if you don't work the edge first, you kind of lose it. So I went on the edge, and I just kept going from one side to the other.
Okay.
One hole after the other next to each other.
My question is about the strength. As that lattice becomes bigger and bigger, the strength of the edge, if you have the whole edge drilled, then you don't have a lot to hold your hand against.
Yeah, this is thick enough. One problem with it I discovered was the near the bottom of the ring, it's an 1/8 of an inch. It's actually a little thicker at the top. I realized next time I'd have to make sure I turn that thinner. And I did hold it. I made a special jig, which I didn't show here, to position the piece in so that there's always a uniform pressure on the sides.
Okay.
I grabbed those pieces that I got. I don't know if you can see these or not.
Yep.
They came in a set, but the spear-shaped ones go right through for you.
That's different than I have seen. Yeah.
Cool.
Great. I'd like to, maybe after you can tell me where you got those. Anyhow, this next slide, the clock, it was another project that I was taking a picture with, and this isn't a turning project, so I didn't know if you'd be interested in seeing it, but the gears do go around. So that was a clock. I make these kind of wooden gear clocks, and I just made that one for my son and finished it up. So that's what that is.
So how many of those have you made?
I've made 3 of those.
Oh, you scroll saw them, I assume.
I scroll saw the face.
Yeah.
The gears on that one I did by hand on a bandsaw.
Wow.
Nice work.
Yeah.
Do they keep
Patience,
time?
They take a lot of time.
Yeah.
And is it run by an electric motor on the bottom, or to keep the time, or how's it run?
Yeah, this is not a pendulum clock. I've made those too. They're more tricky. This is a 1 RPM clock motor that you can buy online almost anywhere. And that's how you run it. So it keeps very consistent time. I have one here in my shop that's been running for 3 years.
Wow.
Keeps great time.
Very good.
Wow.
Have you got a diagram of the gear layout that you could share?
Not with me, but I could.
In the world, if you could send it to me, I would forward it if anybody's interested. I know I am.
I don't. I'll have to look for it. I'm not sure if I have that anymore, but I will if I have it.
I had it out of an old Constantine set of plans, maybe 45, 50 years ago. And the clock ran very nicely for about 1 minute.
Well, the problem with the original plans were they were done by a machinist who built gears for, and gears, machinists built gears for automotive use. The problem with clock, there's always 2 sides on a machine gear that's touching, 2 or 3 sides, and you don't want that in a clock because there's too much friction.
So Ted, while we have you on the line, you're in central Vermont, is that right?
I am in central Vermont, yes, near Sugar Bush.
You belong to an AAW club up there?
Yes, Woodchuck Turners of Northern Vermont.
And where do you meet and how many members?
We've got, I believe there's about 50 members now, roughly. We have, in the summertime, we meet at a very nice shop at one of our members, and in the wintertime at a school, although obviously for the past year, we haven't done that.
Do you meet virtually? Are you doing Zoom calls, or do you have plans for?
We're meeting with Zoom calls, just like this one.
Yeah. All right.
That's
I was sitting over watching you guys on my TV, so it's more comfortable over there.
I was thinking.
What I've been working on is a platter for, it was actually a President's Challenge for I think it was the first state woodturners in Delaware. And they were working on platters. So I took this, and it's a natural edge platter. And there is some bark on the foot. And I think it turned out, I really like it. It's a piece of cherry. And I haven't put any, no finish on it at all. So,
how did you sand the wings?
Actually, I just used the angle drill and went down it like this, kind of very carefully. The inside was easy to sand because that's turning, of course. But then when I got to the wings, I just sanded it, across with the angle drill while I was on there.
Was it spinning when you did this?
No, I didn't have it spinning.
Okay.
No, I didn't have it spinning because I didn't want to knock off any of the bark.
Yeah.
You know, and finishing the bark for me, I don't know if I actually want to do it. You know, because it would definitely not look the same. I don't want a shiny bark. And then we were making some birdhouses, and of course this is not a birdhouse.
Lost your spotlight.
How can you tell?
Bird feeder. This is a bird feeder. I ended up with a bird feeder instead of a birdhouse.
Okay, so you
We're
can
trying
put
to figure out how to put some seeds in it.
Put some hummingbird nectar in it.
Oh, that'd be awesome. Oh, and I bought little birds off of Amazon. We were talking about that the other day about the bird houses, and I thought these birds would be fine. So I bought a mess of them. They were like $12, right? So look at these. I thought these were going to be the same size. Let me see if I can get them up here. Oh my God, the miniatures. They were.
Those are pretty tiny.
They were so small that I can't even use them. You know, they look bigger in the picture. Nice birds, but they're too small.
Kai might be able to do something with those for you.
Oh, the little ones? Oh yeah, you can put them in his little.
I'll make
there you go.
Bird houses.
Yeah, there you go.
Well,
I don't know. They're pretty tiny.
Before we wrap
But
up,
if anybody can find me some hummingbirds, for this one, that would be cool.
before we wrap up today, I'd like to ask you guys who are from whatever club you're in, are you guys intending to try to hold hybrid meetings where you have Zoom participants and real world participants enjoying a meeting together? If your club is planning to do that, give me a show of hands so I can see who's got their hand up. Harvey, Bill, Bruce, Quad State, Mike Lebo. Yeah, pretty much everybody's going to try that. What are you using for screens and computers? Does anybody know?
Oh, I don't know.
Existing large screens, and I guess where our meeting site already has really good internet access, which is a plus, but we haven't really worked out the rest of it yet. And I think we're still, quite a number of months away from getting there, but my goal is certainly before the end of the year that's going to happen.
We're thinking it might happen as soon as summertime, given that quite a few of our members are already vaccinated or are in the process of it. Bill Blazek, what about you?
Well, my club, Prescott Woodturners, have been meeting at the place where we have the meetings for the last 3 months. But it's absolutely stupid to watch these people. The demonstrator starts off with a mask, halfway through no mask. They pan the audience. Half the guys are sitting there with their mask below their nose. It's just insane.
How do you think it ought to be done?
I don't think they should do it until they had their shots, to be truthful with you.
Yeah. And where are you again?
This is Erie, Pennsylvania.
Erie, PA, yeah. How big a club is that?
Well, I don't know what it is right now. When I was the president of the club for 10 years. We had roughly 70 to 80 people. But after I left, things happened in the club, and they're trying to build it back up now. They maybe have 30, 35 guys right now.
So do they have like an in-person meeting combined with a Zoom meeting? Is that what they're doing?
Yeah.
Yeah.
Yes. Exactly.
Anybody else doing that? The reason I'm looking, of course, we're talking about it in the Lancaster Club and considering what we need to buy and how we're going to handle it. And it feels like it's rather than later.
In the Vermont Woodturners Club, we're going to do what you just suggested. We're going to have live meetings when we can. And we're also going to have the Zoom meeting at the same time. So I think that'll probably become standard.
Sounds right to me.
We're in the process of buying.
Bill, you waving your hand?
Yeah, is that Lancaster going to have a symposium this year?
I'm not sure. Ron, do you know? Can't hear you, Ron.
Sorry about that. Yeah, we had board meeting recently. We decided not to make it a public broadcast yet, but no, we're not going to have a symposium live. They're going to try to put together a couple hour demo or whatever they can do yet. Then when they announce that, they were going to announce it. But no, there will not be one this fall.
Okay. All right, and on that note, this is the end of Woodturners Coffee Hour number 48. Thank you all.
John, do you have a moment?
Yes, who's there?
This is Bob. I sent an email to Mark the other day. That poplar I talked about a few meetings ago is down and the wood is available. So if you'd like to put that information in your follow-up letter to anybody who might like some, that would be fine. And then they can contact me and I'll give them addresses and so forth.
How would you like them to contact you? With your email?
Email is fine. I also gave up my home phone number. So either way they want to contact me and then I can give them in case they have questions. And I also sent a picture in case they want to see what it looks like. I have some really large pieces. I'm not sure what people would want.
Did you send that to me?
I sent it to Mark.
To who? I want to broadcast. I want to put it out to the club to this list. If you can send it to me.
Okay. Well, I can resend it to you today if you like.
Appreciate that. Thank you.
All right.
Anybody
John,
else?
if you're interested, yeah, John, you said you wanted to see more of the drivetrain. If you want to stay on, I'll show you the one in the shop here.
Okay.
7 o'clock.
I will stay on.
I'm sorry. You know what I said, Mark? That I meant Doug. Doug has the email. If you'd like to send that to you. I'm sorry.
Yeah, Doug, get it from Doug. Perfectly good. So I'm going to declare the coffee hour and over and hang around and see what Ted wants to show me in his shop.
Thanks once again.
Thanks, everybody.
Thank you.
Good job.
Thank you.
Thanks, everybody.
Thanks.
Thanks, John.
Stick around, can come with me to Ted's shop. What do you got, Ted?
Okay. Well, let me, I have another clock that I originally did in the shop. The one I showed in the pictures is not here anymore at my son's house, but he works at the drivetrain. So I don't have a drawing, but I'm going to show you on this particular clock. Let me, can you see that okay?
Yes, we can.
All right. I'm going to turn it around and you'll get a better view. I mean, all clocks have the same drivetrain as far as the gearing goes, whether you use a, whether you use a pendulum, which, clicks every half second, or you use a motor. In this case, you can see the little metal motor in the bottom.
Yeah.
And the drive gear, which you can see going around. And in this case, it's a 1-to-1, which goes up to the next level of gearing. And then it's, I don't know if you can see if you can see it very well.
Yeah,
then it goes to the upper gears through where it goes to 60-to-1 and then another 60-to-1, and that's how you get your seconds, hours, and minutes, obviously.
Very fast.
Oh, I don't know if you can see that very well here. Here we go. Whoops, got to turn it back around the other way. I got my wire in there, but that's all there is to it. And it's been interesting because in the wooden gears, the first time I made this one, in the summertime when it got real humid, it would stop. So I had to fiddle with the gears. And actually on this one, this was the first one of this type that I made. And I used a CNC machine to route the gears, and I didn't like it. So I went back to doing it by hand on a bandsaw. What I like to do is use a metal blade, a 1/8 inch metal cutting blade on the bandsaw, and you get a much nicer cut. You still have to do some sanding.
Now, are you trying for an involute tooth, or are you trying for more of just a sawtooth?
These are more of just a sawtooth. I've done the involute tooth. Those tend to be more of a problem. What I'm going to do, the problem is these gears were made out of Baltic birch. And Baltic birch still moves because these are only 1/4 inch. What I'm going to do on the next set is do segmented gears. So I'm going to do segmented pieces, you know, like it, and except I'm going to turn them into gears so all the grain is parallel. And I don't believe they'll move as much. Most of the that I've seen, you know, examples of that, and I think that's a much better way to go. So that's anyhow. I don't know that clock, but the nice thing is these one RPM motors work great.
That's very cool. Thank you.
Sure.
Comment on that from anybody since we're here?
Per minute. Wow.
Can you buy a kit that already has them cut out and put it together yourself?
No, that's not a kit. That's I didn't do the design myself. That was a design that was set up for a CNC. And I didn't like it because you could do it on the CNC, but there was no diagram, no specifications. And as an example, you'd put the boards in, and because he had set it up to run in the CNC. So when you do that, it's okay, but when you go back to put the gears together, his instructions, well, you know, just mesh them up. So I don't like that. I have another set. The next one I'm making is from a set. The first one I made was from a set of plans, and that is much better. That's a pendulum clock that I don't have here anymore. And the next one I'm making, I'll never make another one that doesn't have a set of plans. So there's a guy in Hawaii by the name of Clayton Boyer who does, if you look him up on Google, you'll find him. And he has all kinds of plans, and his plans are very good and very detailed. And that's what I would use next time.
Very cool.
Yeah, I knew you made it by hand, but what I meant is, could I buy a kit somewhere that have the same idea, but I wouldn't have to cut all the gears?
Yeah, buy a kit where you wouldn't have to cut the gears. They are available. I'm pretty sure they are. I've seen them, but you'll have to do a Google search for wooden gear clocks kit, and that'll pop up.
You can also get a kit that's made out of foam board and cardboard that actually does work, and you could trace those. One of my sons made one of those.
The best way to do it, if you're going to do plans or even the kits, if you want to I always take the plans and I copy them on my printer, and then use a little 3M tack glue, and I glue the plan down with a piece of wood, and you use that. Just make sure your printer is set to 1-to-1, because printers aren't necessarily 1-to-1 until you have to check that.
Or reduce them all proportionately.
So, John, you mentioned years ago making a set of plans. I did that. I got a set of I can't remember the name of the plans, but they were very popular out there. The clocks never worked.
It was Constantine's.
Yeah, the clocks, because of the gear design, they were never going to work. So, but I remember it was like in the 80s, and I took them to work and I copied them on the big photocopier. Well, they come out oval. In fact, I'll show you what happened to those gears. They're hanging. Well, probably can't see it. They're hanging on the wall, but they make good wall ornaments, because I made a few before I realized that I looked down at, oh my God, if you put if you check the circle, it's not a circle. But the gears, you can see it's got the type of gears if I put them up.
They're engineering gears.
Yeah. And if you put those together with another, there's too much friction. So clock gears are significantly different than that.
I found that with a lot of graphite and a lot of filing, I could get it to run, but it didn't run very long.
Yeah, that's the problem. They don't run long. I mean, you can get them to move. All wooden clocks are a problem with. You usually have to have a lot more weight. But if you now the other thing is, the first one I made had wooden arbors, and the one I just showed you, I used brass.
That would help.
So the brass arbors are the way to go. Trying to do a wooden is very difficult to get it to run.
What did you use for bearings?
There are no bearings. It's just the brass
So just a brass bushing?
Correct.
A little bit of white glue, white graphite would do pretty good. A little bit of powdered Teflon in there would do all right.
Yeah, I use a synthetic oil, and that'll last forever. And they work very smoothly. That one's been working about 3 years now, and I haven't done anything to it as far as lubrication goes. So I have another one from Clayton Boyer, which I'm going to start here soon, as soon as I finish this airplane that's on my bench. And that one I'm going to, and his are wooden arbors. I'll modify those and make them brass. I actually thought about, you mentioned bearings. You know, you can buy I fly remote control airplanes, so I do a lot with that. And there's a lot of little miniature bearings for those. I was thinking of actually doing miniature bearing arbor. Also, I'll probably play with that.
I've been using skate wheel bearings to make steadies, and they have an 8mm hole, which is basically 5/16. So, and they're pretty cheap. You can get 10 skateboard bearings for a few bucks.
Oh, bearings are expensive now. You can get those.
Particularly the small ones. Yeah. You can get them over at Lowe's or whatever. Yeah.
I get them on Amazon. I had to get some for my bandsaw, these little ones, and you can get 10 or 20 of them for a few bucks.
Yeah.
Could you spray Teflon on the actual gear itself so that it doesn't have the friction between the gears?
You can. I didn't. What I do is I tend to I saw the gears so they're close, and then I use like a 240 sandpaper, and then I wax them. Wax works very well.
Yeah, wax would do.
So the wax, you kind of put the wax on and then kind of burnish it with a Dremel tool kind of thing, and that seems to help a lot. Now, I think, and obviously the wood makes a difference. I do not like the Baltic birch. The smaller gears on that one are maple, and sure, they work much better because it's got a nice, when you cut the end grain, you can still smooth it out very nicely, and that makes a huge difference. So it's a fun project to do. The next one I'm going to make will be like that, and it's going to be a pendulum driven. I don't have pictures prepared. I'll show you another time a video of the first pendulum one I made in 2008. It was and I bought that design from a guy, and it worked well for short periods of time. The problem with that one was the frame was not steady enough and the gears moved too much. So I got frustrated with that and took it apart. So I modify the frames usually. Fortunately, the ones from Clayton Boyer, his frames are much better.
How many hours? Any guess?
I have no idea.
Oh, time sucks.
It's for fun. I don't look at the hours.
So will the clock run longer than the hours you spent building it? That's the question.
Well, these electric ones have. I don't know about the pendulum ones. Most of the guys that build pendulum clocks, they always have trouble in the summertime when you get into high humidity situation. It's very difficult to make a wooden gear clock with a pendulum that consistently runs.
Well, the old ones, though, there's a lot of 18th century ones and 17th century ones around that are they're much smaller gears, but they're wooden gears. They're usually made of something like box or pear, something that's really stable.
They are. A friend of mine has a clock business in Randolph, Vermont, which he sold to his son and running in. And it's all antique clocks. And he has wooden gear clocks from, original ones. And when he has to replace a gear, he'll take a block of wood, he'll machine it, let it sit 6 months, machine it again, let it sit 6 months, machine it again. And I'm like, you could stick it in the microwave, it'd be a lot faster. He said, what? Those clocks, those are easier to make because those gears are smaller. And those gears were set up just to duplicate the brass gears remember, these wooden gear clocks were made in the colonies because England wouldn't send them the brass. So that's how all that started. And they still run for years, but they're smaller, thicker gears, and they're running off a wound spring, which is very, very tight. So you get a pretty good, consistent movement, and those clocks have been running for years.
Wow.
This is pretty interesting. So I went down there before I built a wooden gear clock to look at those, but they're so different. The object with these is to show the gears, and you can see how large those are. They're 8-9 inch diameter on the larger gears, and the problem with that is they move around a lot.
Thank you very much, Ted. Appreciate it.
Yeah, certainly.
Thanks for showing.
No, thank you.
Happy to.
Up in Vermont, you have long winters, so you don't care about the time it takes to make a clock, right?
Harvey, he's commenting on our winters.
And the nights are so long that having the seconds stretch out is just to your advantage.
I'll have you guys know about Vermont. There's I have an article that I had years ago that I had hanging in my office, and it says there's a bumper crop of inventions in Vermont, and there was over 5,000 of them. I won't get into which ones, but the point is, in Vermont, everybody had a wood shop, and everybody had I live up in the mountains. I'm at 1,500 feet, and 200 years ago, this area was all sheep farms. And, the stories go, when it snowed, you didn't leave. You went from your house to your barn, and what you did was you worked in your shop on the equipment. And that's why there was a lot of tinkering done here, because they couldn't do anything else. Sort of like this whole year.
Well, and the other part is that the furniture makers of the time would get farmers to do spindles. So you could do job work out in your barn in the wintertime on a lathe and get money for it. So it's another paying gig. Of course, you couldn't ship them till the spring, but when you see all these Windsor chairs and stuff like that, it's because some farmers were out there turning spindles.
Yeah, the plow. John, you're on mute, by the way. A lot of the, but it's interesting, this article I had, which I like to keep in my office, was all about the bumper crop of inventions coming out of Vermont. And it wasn't just Vermont, these were Vermont, but obviously all around New England and other areas where you got stuck in your shop, in your house, in your barn all winter long. It's pretty interesting.
There's a precision museum, I think, in Windsor that has a whole lot of miniature, small engine, steam engine kind of stuff, all in gear works and things, if I recollect right. Do you know about that?
No, where is it?
Windsor, I think.
Oh, Windsor.
Yeah, Windsor, Vermont. I'll find out. Harvey, Harvey, your volume's low. Say it again.
Can you hear me at all?
A little bit.
Very faintly. Now I can't hear you at all.
Yes.
There you are.
There you
are. Let me just see what's going on here.
Welcome to the meeting.
Yes or no?
Yes.
Now.
Yeah. Anyway, my father-in-law worked for Bryant Grinder in Springfield, which was a major machine tool development center in Vermont, and Windsor, that Precision Museum, he was on the board there, and they did have a lot of stuff on rifle making and so on. It's a pretty interesting museum.
Very interesting stop for anybody interested in mechanisms and gizmos. Yeah.
Cool.
Yeah, check this out. We talked about the gears. I found some of my other ones, and you look at how these gears were meshed, where you always had teeth coming together, and that doesn't work. I'll go find the diagram of the next one I'm going to build. They don't look like that at all.